So we're solving radical equations today. 5.8 we're going to do in 2 days. Today we're going to focus on the equations that have radicals and rational exponents, and then there's going to be some more extraneous solutions. These are going to be a little bit different with the checking methods than we did in the past, so we'll talk about that today as well. So the first thing we're going to think about are radical equations and their inverses. So we already did talk a little bit about this yesterday. When you're undoing any type of function, you have to use the inverse. And what is the inverse operation of a root or a radical? So think about what we talked about yesterday, right? We wrote out if it's the square root of x, what's the inverse? X squared. So you square it, right? The inverse of x cubed would be the third, right? X to the third. So the inverse operation of a root is a power. The inverse operation of a root is a power. So when we see a square root and we want to solve that equation, we're going to raise each side of the equation to the second power. So for the square root, if we're raising each side of the equation to the second power, think about what that means for the cube root, the fourth root, the fifth root. Okay, so to undo a square root, we raise each side of the equation to the second power. What are we going to do for a cube root?
Raise it to the third power.
Yeah, raise it to the third power. The fourth root would be the
Fourth power.
fourth power. The fifth root would be the fifth power. Okay, so we're just going to write that shorthand. Okay, so for the cube root, you would do the third power. And we're also going to write out what this is going to look like. So for the fourth root, this would be if you had something underneath the fourth root. Okay, what you would do is raise each side to the fourth power. Right? If it was the fifth root, you'd raise each side to the fifth power. Okay, so on and so forth. So now let's think about this in the reverse. Let's think about the powers. So the inverse operation of a power is going to be a what? A root. Yes, good. A root or a radical. Okay, it's just like with addition and subtraction. Addition undoes subtraction. Subtraction undoes division. Okay, a power undoes a root undoes a power. Okay, so if we have a quantity, I should say raised to the power of 2, what we would do is you could take the square root of both sides. Whatever you would do to one side, you do to the other. And for the power of 3, we would take the cube root of both sides, and then so on and so forth. Okay, so our focus today, we're going to have roots, we're going to have powers, and we're also going to have rational exponents. You guys remember what rational is? What does that mean? Hello. Miss Whipple's room. Yes. Yes. No, we're doing notes, but at the end of class, they'll have time to do their homework. Is it okay if I send her down there? Yes. Yes, I will. Okay. Yep, fine. Okay, right, so with the 1/2 power, remember, the 1/2 power is the same thing as the square root. So when we're thinking about if the power was a fraction, okay, what would we do to simplify? So we just talked about, this is the same as a square root. How do we undo a square root? We square it. So we're going to square both sides. So we'll do that part together. And Sam, so I don't forget, after we do the notes, you're going to go to your AP Psych class or poster board something. Oh.
I'm so tired. I get so much pain.
All right, so now that we have the powers, right, if we have, think about what's happening. So yeah, the square root undoes the square because they're inverses, but if you have a power to a power, what's 1/2 times 2? 1. So this is just x, right? And then 3 squared is? 9. So then this would be your final answer. Okay, so based on that, did you guys do number 2? Yes, sir, Bob. And then make sure you write out what you're doing to both sides. So you're going to put them each side in parentheses, okay? Okay, so Jack, what did you do for this one? So not multiply, but you, yeah, so raise each side to the power of 5. So if you do this to the 5th power and you do this to the 5th power, 1/5 times 5 is just 1, and then 2 to the 5th power is 32. Okay, now 3 is a little bit different. So we've been raising each side to the powers, okay? If we have x to the 2/3, remember, what's been happening here is when you multiply, you get 1. So if you have x to the 2/3, is there something I could raise this to that would make that 1? Yeah, what? 3/2. Do you guys remember what that's called? Yeah, great. Okay, so we're going to use the reciprocal. So 2/3 times 3/2 is 1. Oh, sorry, I forgot. I wanted to change this to +2, and I forgot. Please forgive me. Do you guys know why I wanted to change it?
So it's easier.
Yeah, you can't take the square root of a negative, right? You wouldn't have a solution. If you got a negative underneath, there would be no solution. Okay, so we are gonna use the same things that we used in the earlier sections. So remember, the 2 is the root, the 3 is the power. There's 2 different ways that you can write this. So you can have the square root of 2 to the 3rd power, right? So you can put the square root here, the power here, and have the square root of 8. Or what's the other way you can write it? Do you have to put the power underneath here? No, you could also, the other way we've written it is having the power on the outside. So this is exactly what we did in one of our last sections, right? Okay, so you have the root and then the power. If you have root 2 cubed, then you are going to have to simplify it. No matter which one you choose, you're going to have to simplify. So you're either going to simplify root 8 or you're going to simplify root 2 times root 2 times root 2. Which really, 2 times 2 times 2 is just the what of 8? It's the factorization, right? If you did the factor tree, you get 2, 2, and 2. Remember, we were just doing a lot of factor tree stuff. But yeah, we've done a lot of practice with simplifying square roots. right? What's the perfect square in 8?
4.
4. So this would be root 4 times root 2. Okay, and then root 4 is 2, so it would be 2 root 2.
Plus or minus.
Nope, so the plus or minus would only come if you physically had to take the square root here. This one is just going to be the positive. That's a good question, though. If you simplified from this, remember, root 2 times root 2 is 2. So you'd be left with 2 root 2. All right, so based on this, you guys really already answered this question. If you're undoing a power that is a fraction, the rule that would work for all of these is specifically what we said for this, right? You can raise each side to what? The reciprocal. And it has some nice alliteration for you English scholars, right? Raise each side to the reciprocal. So raise to the reciprocal. You guys have been doing alliteration, right, in your classes? Yep. Okay, so raise each side to the reciprocal of the rational exponent. So you have to look at that exponent. Whatever the exponent is, that's how you know what the reciprocal is. All right, now, in order to use these strategies, it is important that when you're applying the inverse operation, that you isolate the radical. There are going to be some cases where you have to have another term with it, and we'll look at those. But for the most part, if you can isolate, you want to isolate. Okay? So the radical expression, or if it's a rational exponent, the base, you want to make sure that you get that by itself. Okay? Now, for example 1, it says to solve each equation and then check for extraneous solutions. So we are going to solve, we are going to check, we're going to talk about the ways that you need to check so that you're prepared to do that on your homework and on your test. When you check for extraneous solutions, the main thing that you're looking out for here are the even roots, because if you have an even root, what's the issue? Yeah, you can't take even roots of negative values. And that's the main thing that we're going to look out for. Okay, so the checking process is going to be a little bit different. You don't have to write this down. I'm just going to remind you of the quick check that we were doing in the last few sections, right? In the last few sections, I said, oh, you don't have to write out everything with your check. You can do a quick check, right? Because if you had a problem like this, when is the only time you get an extraneous solution? If you had x was equal to -2, because that was the only restriction in the domain, right? You couldn't have 0 in the denominator, okay? So you only had one value to watch out for, but with even roots, you can't take the even root of a negative value. How many negative values are there? A lot. There's an infinite amount of negative numbers. Okay, so it's not going to be a check where you're just checking for one number. You actually have to plug the number back in. And so we're going to talk about the rules of checking today. Okay? All right, so for A, the first thing we're going to do is isolate this radical. So the plus 5 is added on here, so we have to subtract it from both sides to get the radical by itself. Did you get yours? Okay. All right, So once you move that over, now you just have the square root. To undo the square root, what do we use? The power, yes, power of 2. Yes, you square it. Okay, so you square both sides. So you have x plus 1, because what happens is the power of 2 undoes the radical. You're left with what's underneath, the radicand, and then you go ahead and calculate. Then, of course, your final step is just subtracting the 1, and then we got to check it, okay? So the reason why we have to check this is because it's an even root. So anytime it's an even root, we're going to check, okay? So when you check, you have to simplify each side separately. Do not perform any operations. Do you guys know what I mean by that? What did you say? Oh, sorry. Took me a minute to think about what I said. Yes, no surgeries performed. Okay, so like what you don't want to do is don't perform operations on both sides. So you can't add anything to both sides, subtract anything to both sides, multiply, divide, square both sides. You can't do that. You can't solve it. Okay? You can only simplify. So let's plug this in. So I'm going to plug in 120. So 5 plus 120 plus 1 equals 16. Now, sometimes the one side is already simplified, so that's great. You really don't do anything with that side. You just have to work on this one only. So sometimes I'll just do this to split it up. This is the 121. What's the square root of 121? 11. 16 equals 16. Yes. That's all you have to do. Okay? You just can't perform operations until you go through medical school. All right, so for part B, okay, for part B, we can still isolate this radical. Okay, so I want you to get this radical by itself and then perform the operation of both sides. You really do want to try to do these without a calculator when you can. B does have some bigger numbers. So for B, you can use your calculator to do those, to do 12 to the third. Okay, so Aiden, Al, will you tell me what you did first for B?
I simplified 7 to the power of 3 at 343.
Oh, did you cube both sides right away? Did you cube both sides?
Oh, I thought 7 was raised to 3.
Oh, gotcha. Yeah, this one is the cube root. So the first thing I would do is move over the 7. You technically could cube both sides, but because this doesn't have a radical on this side, to deal with smaller numbers, I would divide by the 7 to cancel those out. So that's multiplication, which is why we want to divide. Okay, and then what did you guys get when you did 84 divided by 7? 12. And then your next step would be to, close, don't cube root, but raise the power of 3. Yep, so you just say cube both sides. And then the 3, power of 3, and the cube root undo each other. And then Dane, what did you get when you did 12 to the third?
1,000.
Yes, 1,728. Okay, and then now we're just going to solve for x. So you're going to add 7 to both sides. So 1735, and then this works out really nicely, doesn't it? What did you guys get for x? 347. Now, this is a cube root. So if it is an odd root, okay, remember we talked yesterday about the cube root in particular. What is the domain? All real numbers. There's no restrictions, right? If the domain is all real numbers, that means there's going to be no extraneous solutions. So you could check these if you wanted to make sure that your math was correct, but you don't have to check these ones. Okay? You have to check the even roots because of the restrictions on the domain, but with any odd root, a cube root, a fifth root, you're never going to have an extraneous solution because the domain is all real numbers. Okay? So you don't have to check. So same thing on your homework. You don't have to check the ones with odd roots. You only have to check the ones with even roots. And I know that some of you started looking at C. Did you guys notice what's a little bit different about this one? Yeah, there's radicals on both sides. So usually what we'd want to do is divide by both sides by 3, but that would just leave us with a fraction over here. If you cannot isolate the radical, that's fine. You're going to have to raise each side to the power of 2. And when you do that, you are going to have to make sure that you apply the 2 to the 3 and the square root. Okay? So when you're doing that, this side, these will undo one another and you're left with the radicand, the 8x plus 6. But here you have 3 squared, which is 9. And what happens when you do the square root of x squared? Yeah, it just becomes x. So this becomes 9x. Okay, so this is one term, but you have to distribute here. Okay? And then you're going to get all of your x's on one side, all of your numbers on the other. You'll get x equals 6, and then that's something that you will check because this is an even root. Okay, so an even root means we're going to check. Now, when you're doing this and you're plugging it in here and you can see that you're multiplying, I'm fine with you just saying, like when you plug it in, 8 times 6 is 48 plus 6. I know for a lot of you that are good at mental math, sometimes the check is painful because you have to write your steps out. But you can do it. Okay, so I'm not going to touch this side. This side is already simplified. The only thing I have to worry about is this side. So 48 plus 6 is going to be what? 54. And then I have to simplify the radical. What's the perfect square in 54? 9. 9 times 6, right? So 3 root 6 equals 3 root 6. So we got the match there. Okay, so based on C, I do want you to start part D. That one is still a little bit different than this, so I'll check in and make sure that you have the right answer down. Okay, so Dane, how are you going to start this one, you think?
Design.
Nope.
No.
You could, you just don't have to.
Where's the power?
Yes. So if some of you were thinking divide and already did that, you could divide both sides by 2. Okay, you absolutely could do that. You just don't have to. And then what you want to be careful of here is you have this 2. So you have to do 2 to the 3rd, which is 8. And then this is going to go in parentheses because you're distributing. So 2 to the 3rd is 8. The cube root of x minus 1 to the 3rd is x minus 1. The reason why you want to put it in parentheses is because what am I going to have to do to simplify? Yes. Okay, so go ahead and finish that one. And then you can start thinking about E. Just be careful with E. That's going to be a little bit different too. So once you distribute the 8, you should get 8x minus 8 equals x plus 6. Subtract x from both sides and add 8. So you get 7x equals 14, so then your x is 2. Okay, this one is a cube root, okay? It's an odd root, so there's no extraneous solutions. And you can just keep that there. Okay, so I warned you that E was a little bit different. Did you guys do the first step? Yeah, the first step would be to do what for both sides?
Square.
Yeah, square. Good. Okay, so we're going to square to undo this part, the negative 3x plus 33. Now, when you square here, sometimes people want to distribute, but you can't do that. Remember, this squared means 5 minus x times 5 minus x. So what do we have to do to simplify that? We have to FOIL. Okay, so I'll give you a minute to FOIL. And I'll let you know that you should, once you solve this, you should have 2 possible solutions. And we will have to check those because it's an even root. FOIL is going. You know what to do after the FOIL? Your goal is to factor. You got to get everything on one side. Or you can move the other ones if you want to keep that squared. you can check your foiling to see how that went. And is there a certain thing you guys notice that tells you when you want to move everything to one side? What do you think? Yeah, when you have enough terms to make a trinomial, because you have the x squared and you have the x. I like to keep my x squared positive, so I'm going to move everything to this side. You don't have to do that, okay? So I'm going to have my x squared, negative 10 plus 3 will be negative 7x. This will be minus 8. If you guys moved your terms to the other side, you would have negative x squared plus 7x plus 8. And that's fine too. Okay, so you can still FOIL that, get the same answers. You could divide everything by negative 1 if you wanted to. Okay, once you have it's equal 0, it doesn't matter what side that goes on. But we do want to factor. So we're looking for two values. Has to multiply to negative 8, but add some negative 1. Negative 8 and positive 1. Negative 8 plus 1 is negative 7. Good. So you get two answers. What are they? 8 and negative 1. So that's what we're going to check. Do you guys think they're both going to work? Okay. If you had a guess, if you haven't done it yet, which one do you think wouldn't work? Well, let's see. Okay, so let's check them. So it's an even root, so we are going to check them separately. So we're going to check the 8 first. So again, when you're plugging this in, I'm fine if you do the multiplication part in your head and write out just the negative 24 first. That's fine. Okay, but the thing with the checking, I know it's a little tedious, but you do have to make sure you write out each step, okay? All right, so now we do have to simplify this side. 5 minus 8 is negative 3, okay? And then once you get that one term, you're good. Negative 24 plus 33 is 9, so you have the square root of 9. Now, when you have the square root already there, remember, it's not a plus or minus. Square root of 9 is just 3. So 3 does not equal negative 3. This is when you have an extraneous solution here. Okay, so this is not going to be part of our final answer. Now let's see what happens if we have the negative 1. So again, when you plug that in, you can have negative 1 times negative 3, which is 3. And then 5 minus negative 1. Okay, and it doesn't matter which side you simplify first. So if you want to do square root of 36 and then 6, this would be 5 plus 1 equals 6. Yay, that one does work. So if you were doing this on test or quiz, on the line, that's when you would just write x equals negative 1. Okay, that's your final answer. Okay? Alright, and go ahead and do F. You're ready for F now. Okay, so F is going to be similar to E, so use that to check your understanding and ask some questions if you need to. Alright, how do you guys feel about F so far? You feel like you got the formula down? You got the factoring? Okay, you can keep going and I'll write down so you can check. make sure we got the correct factoring here. So I moved everything to one side to get x squared plus x minus 12, which is going to factor to x plus 4 to x minus 3. Multiplies to negative 12, adds to 1. So that's going to give me x equals negative 4, and x equals 3, and it's a square root. So do we got to check them? Yes. Okay, so x equals negative 4. Let's make sure you guys did the check correctly. So again, I'm fine with you just multiplying this here to write the 36 plus 28. The rest of the stuff we're going to make sure we write out. You have a negative 4 here plus 4. Okay, 36 plus 28, what's that going to give you? Good. Square root is 64, and then this is 4 plus 4. So you'll have 8 equals 8. All right, great. So that's one of our solutions. Notice that the negative answers that we got here are not producing the extraneous solution. So don't just go by if it's negative or positive, okay? And then let's try x equals 3. So when you plug in 3, you get negative 27 plus 28. On this side, you get negative 3 plus 4. Negative 3 plus 4 is 1. This is the square root of 1. What's the square root of 1? 1. Okay, so they both check. So that means in your solution is x equals negative 4 or x equals 3. It can be either one. That's your final solution. They both checked out. All right, how you guys feeling about that? Pretty good? Going to do some rational exponents. This is what we talked about the first thing today, right? So if you have a fractional exponent, you can raise both sides to the reciprocal. And then what that looks like, I'm going to use brackets because we already have parentheses here. So you're writing it as a power. So you have 5x plus 7 now, because 1/3 times 3 is 1. 3 cubed is 27. And we just have to solve this for x. So go ahead and do that. Okay, so what did you guys get? X equals 4. Okay, and again, this is an odd root, so there's no extraneous solutions that you have to worry about. If you do want to check it just to make sure that you did all your math right, that is fine. It's just optional. Okay? So if you did want to check it with this, you would just plug it in. 5 times 4 plus 7 to the 1/3 equals 3. And then the main thing that you don't want to do when you're checking these types of problems is you don't want to raise each side to the 3rd power. Okay, you just want to deal with this one side. So this would be 20 plus 7, 27 to the 1/3, which is the cube root of 27. So yeah, we did all that right. Okay. And then for h and I, they're 1/2. So 1/2 is the square root. So you are going to check that. So remember, the bottom number, that's the root. So if it's odd, 1/3 is the cube root. That's how we know that it's an odd root. Okay, so Ashay, what are we going to do first for this one?
Square rooted.
That's not what you mean, but
Raise them both to the 2nd power on both sides.
yes, good. Yep, so the 1/2 is the square root, so we're going to use the power. Also, 1/2 times 2 is going to be 1. Write down what you think this side's going to be. Okay, so for this side, you either wrote down one of two things. You either wrote down 2x squared or you wrote down 4x squared. Which one is it? 4x squared. Okay, so you have to do 2 squared and then the x squared. Okay, it is really easy to forget to apply that. Okay, so you are going to make sure that you have it there. Okay, now look, we can make a trinomial. Anytime you can make a trinomial, what do? Yeah, and before you factor, you got to get, yes. When you're factoring, what's the first thing you should do in your factoring sequence?
Figure out the greatest common factor.
Okay, yeah. So does this one have a GCF?
Yeah.
More. 4. Okay, so then go ahead and do that. Yes. Yeah. Which is the reason why I do that is you have positive. I like my first one with positive. But because it's an equation, you can also get it.
All right.
Alright, so did you use factor it? Okay, and then
Oh, wait.
Yep, and then we're going to solve. Okay, now once you factor it too, sometimes when we factored this year, we haven't been solving. We have just been factoring. But when you're solving, what's really nice is it's equal to 0. So what you could do to both sides at this step, is you can just divide both sides by 4. Okay, because 0 divided by 4. And you can do that in the next step too. So if you already factored, you can still divide both sides by 4. And that's fine. So now we're looking for something that multiplies to -2 but adds to -1. -2, +1. So your two possibilities are x equals 2 or x equals -1. Okay, so 1/2 is the square root, so it's an even root. So we got to do our checks. Our checks and balances. You guys learning about that this year? Oh. Yes? It's within the government. Yeah. It's been a long time since I learned that. Well, are you guys in government this year or last year?
Yeah,
Okay, so if x equals 2, we're going to plug it in, so it's going to be 2 times 2 equals, and then in parentheses, 4 times 2, and I'm fine if you just put in the 8 is fine. Okay, and then from there, this side is the one that's going to be quick. And again, do not perform any types of operations here, okay? You're not a licensed professional. I think I'm going to use that. People will remember that. So Dylan, thank you for my cheesy jokes of the day. Alright, so 16 to the 1/2 is the square root of 16. Square root of 16 is 4. That's equal to 4. That's great. Okay, now we're going to do something similar with x equals -1. So when you plug in -1 here, it's 2 times -1 equals, and then again, if you want to do this multiplication to write -4, that's fine, plus 8 to the 1/2. So on this side you get -2. This side we're going to have to write out our steps. So 4 to the 1/2 is the square root of 4, which is 2. Does that equal negative 2? Nope, so that is extraneous. So then your only solution, the only thing you would write on the line is x equals 2. This would be the only thing that you'd have. That's your solution. Okay, and then for part I, you can really decide. You could square both sides at this point, but see how you just have a number on this side? So to make your number smaller that you're dealing with, divide first. Okay, so if you divide first, then you just have x plus 6 to the 1/2 equals 3. Okay, you do have to make sure that you're showing this step that you're squaring both sides. And then again, this is an even root, so we want to do our check. Okay, so I'm going to let you guys see if you can do that on both sides. And this side you should be leaving alone. Okay, so it's 3 plus 6 to the 1/2. So we aren't doing anything with this. Do not divide. You're just going to simplify. So 3 plus 6 is 9. And well, you can just leave that. That's already simplified. So this is 3 times the square root of 9. What's the square root of 9? 3. 3 times 3 is 9. Yay! Okay, so I'm going to give you some time today to start on this. Some of these are going to go pretty quickly for you. And you only, for this first section, the 1 through 21, you only have to do the odd numbered problems. Okay, so you only have the odds. And then those you're going to do all. So only the odds for this.
Is it first?